"Oh my God, what's that?" The phrase reverberated from backyard telescopes to the clinical consoles of mission control as, on the 1st of July, 2025, a pale, quiet speck blinked into human sight just beyond Jupiter and at once set about redefining everything we'd imagined about travelers from the deep. It began as simply a sluggish blur nested in the Chilean Atacama sky's plushness, a fleeting imperfection among so many points, and most observatories were dismissive of it as of any other curiosity, catalog, log, get on to the next thing. But as telemetry streams accumulated from locations throughout the southern hemisphere, there arose an obstinate, unexplainable consistency. The object was not orbiting the sun, it was on a linear, inward path, a course that made evident within hours what had been speculated upon in theory but demonstrated only 2 other times previously in recorded history. Something had originated between the stars and was slicing through our neighborhood. In the silence of telescopes and thrum of cooling units, the designation came almost as an aside, 3I/Atlas, the third interstellar object known, and unlike the first 2 to make it, it refused to present itself as a mere clump of rock or ice hurtling on some arbitrary vector. Instead it came bright, swift, and obstinately whole. From the little reflector of a home observatory on the volcanic plains of New Zealand, Sam Dean saw a twinkle that would have been ignored by most as an artifact, but he reran the sweep and the target remained, speeding, coherent, incorrect. He signaled Atlas, the asteroid detection network designed to identify things that would strike us, and the network that had been established to protect against known threats realized with a shock that this was not known at all. When the Jet Propulsion Laboratory incorporated the new information into its models, the figures were brutally unequivocal. The guest had traveled from much farther than the Kuiper belt, its speed of approach greater than Oumuamua's, its luminosity higher than Borisov's, and its spectrum a perplexing combination of silicate ices and something else, darker, metallic maybe, even magnetic. Within days, instruments on 4 continents and a handful of space telescopes had been red-asked, Chile's VLT, Hawaii's Pan-STARRS, arrays in South Africa and the James Webb Space Telescope itself turned lenses, mirrors, and detectors toward the small, fast point of light, and the same frustrating result repeated. Every instrument seemed to insist on its own truth. One array captured a thin blade of reflected light, another a broad arc with no definable central mass. James Webb's processed frames indicated segmentation, not junk but intentional sections, and thermal overlays would not conform into a coherent, consistent image. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel Spark Science, and share it with someone who should hear it. Let's get started. The borders were warmer than the interior as if heat was being actively emitted from the surface. The object did not just passively reflect the sun, it reacted. Light curves that would have been textbook rotations instead yielded a disquieting string, flashes of brightness that, when fed into harmonic analysis, came back a rhythm of primes, 11 seconds, then 13, then 17, an organized pulse in the noise that calcified suspicion into fascination and dread. Before 3I/Atlas had even crossed Mars's orbit, scientists were no longer disputing whether it was alien, they were disputing only the hue of that possibility. The first indication that it could be more than an odd-shaped vagabond came in the form of a hole in the radio spectrum. The square-kilometre array Pathfinder in Western Australia detected a thin line of missing transmission at the 4.83 GHz band, not distortion, not noise, but a clean gap where transmissions we use for deep space telemetry should be. A re-examination of historical Arecibo data located the same shadow behind the object weeks before. At first, engineers grumbled the usual laundry list: equipment malfunction, atmospheric interference, calibration problem. And then a postgraduate student in South Africa took the dataset, performed a reverse FFT to trace the silence itself, and the resulting pattern was far from blank. The void took form, a modulation woven into the absent frequencies as if a hand had snapped a single string from an orchestra and molded the surrounding silence into a waveform. It was the kind of outcome that freezes fastidious individuals into silence for a moment. 3 weeks from discovery, a thin, narrow pulse, 3 clicks, 2 clicks, 5 clicks, crept into the world on the same band that humans earmark for interplanetary space communication. It was small, fleeting, simple to overlook, but it was patterned, not random. And then, sort of as if rumors solidify into facts, a civilian ham radio operator in Nevada uploaded a recording of the very same pattern, and the web did what the web does best: it blew the signal up into a din. Within a dozen hours the private humming of observatories was turned into governmental tremors. Radio dishes, defense ministries, and foreign offices that had maintained a studied silence had to admit that the sky had been spoken to and that whatever replied might be listening in turn. The first international response was subdued, not melodramatic. NASA's Deep Space Network redirected dishes and threw all spare processors into signal lock. Spain, China, India, and European centers synchronized relay chains to maintain uninterrupted lines of sight. No press releases, no live shots, merely a storm of secret orders, spliced schedules, and technicians who had just been given a question without an apparent answer. Is this a greeting, an interrogation, or a test? 3 days later, something else altered shape. Weeks of disagreement among telescopes on the outline of 3I/Atlas finally resolved into July's thinning nights, when Kyoto and the European Southern Observatory noted faint flares along the edges of the object, short, localized pulses of heat that changed the apparent shape from smooth to subtly asymmetrical. What had looked like a plain ovoid now revealed an edge strained taut, another compressed. Warmth appeared to radiate outward in a slow, rhythmic beat like a pulse. Natural forms don't do that, they fall apart, shatter, release dust according to predictable patterns. This thing appeared to be aligning itself, holding vector, forming structure in midair. The ramifications were incendiary in their silence. If it wasn't wreckage, and if it wasn't a stupid chunk of ice, then was it inhabited? Was someone regarding us? And if someone was regarding us, were they interested, apathetic, or calculating? The need to answer that question fueled an international race against time. Due to the approach angle, 3I/Atlas's closest approach to the Sun, its perihelion, would come when Earth was on the opposite side of our star, making the object invisible to some of the telescopes that had been focused on it. The most scientifically useful window for observing sublimation and composition was just the time it would disappear behind the Sun's brilliant light. So nations and observatories rushed to wring out every measurement possible in advance of conjunction. France sent stratospheric balloons aloft to get instruments above atmospheric shimmer, Japan calibrated lunar infrared platforms, the Vera Rubin and other next-generation observatories hastened commissioning schedules, and JPL pushed radar sweeps at the margin of sensitivity in advance of uncertain returns. There was, in all these urgent, deliberate maneuvers, a shared understanding that this could be a once-in-a-civilization opportunity. Chemistry could be the message, and chemistry would endure the journey. Spectroscopy crews manned the shifts, deciphering the weak color bands of a dwindling coma that still read, on the first pass, strangely familiar: water, carbon monoxide, organics traces, a whiff of home in molecules, much like our comets, but skewed in nuances. The carbon-to-oxygen ratios remained just beyond the realm of known limits. One group raised an unknown molecule, a stable compound that didn't fit any entry in the catalog. Suddenly the venerable SETI truism, that if a civilization wishes to communicate a message, it may inscribe it in chemistry instead of radio, seemed less philosophy and more working hypothesis crying out for instant test. As 3I/Atlas curved around toward perihelion, the planet gasped behind its closed doors. The models indicated that it would not be pulled into the Sun's gravity, it would steal the star's heat, show us what it would show us, and then go on a path that would send it out of sight for months and, most likely, years. Calculations put its return in early December, fainter and further, and by 2026 it would be passing the outer planets and, by 2027, falling back towards interstellar darkness. The realization that the window for close-up examination was brief stiffened priorities: acquire the spectra, acquire the high-resolution thermal maps, reap and store any anomalies. But even as the instruments took their readings, a deeper philosophical argument propagated like light across pages. Were these three interstellar guests, Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025, simply random, relics of a time when our instruments had finally become attuned, or were they proof of something else, some pattern? Maybe an avenue of interstellar material guided by gravitational currents, a passing star, or something more intentional? Prior to 2017, mankind had counted none, in a period